This is the spiral review for number 6 literal equations for algebra 1. Each of these asks you to solve the following equations for the given variable. In other words, we're rewriting equations solving for the variable that asks to solve for. Number 1 says P equals IRT, solve for T. Well, first thing you want to do is isolate the term that contains my variable. This is all one term. So all I got to do to separate the multiplication is divide by I and R. And T equals P over I R. You could also write it as T equals P over I R. That would be the symmetric property, which allows me to switch the order. Number 2. Same setup, A equals 2 times the quantity L plus W, solve for W. Now there's two ways to do this. I could, of course, distribute the 2, or I could realize what I like to think of it as, these are two terms that I have to separate, but I can't separate them yet because they're all kind of held together in one bag. And 2 is the seal on top of the bag that I have to dump them out of the bag before I can start to separate them. So if you subtract L, that's incorrect. The first thing you actually want to do is divide this whole thing by 2 and divide this by 2. And what that will do is separate these two terms, L plus W equals A divided by 2. Now these terms are separated, they're not glued together, the entire quantity. I can just subtract L, and W equals A divided by 2 minus L. So again, A over 2 minus L equals W. You could do 1/2 A minus L equals W. That's the same thing as number 2. Number 3 gets us into a phrase that you'll hear me quite a bit say. This says solve for X. So I'm going to solve for X. There are two terms. The first thing I want to do is isolate the term that contains my variable. On the whole equation, there's 1, 2, 3 terms. This is the term that has my variable I'm looking for. So I want to get this entire term by itself first. So first I'll add 6, and I'll add 6. Now y plus 6 equals 5x. Now my term has been separated. Now that my term is separated, I'll do the multiplication. I divide that by 5. I divide every term by 5. I'm going to kind of look silly. Let's get in the habit of dividing every term by 5. It's y divided by 5 plus 6 all over 5. Now, of course, if you had this equals, you could say x equals, instead of y divided by 6 plus 5 over 6, you could have y plus 5 all over 6. That is equivalent, but again, we want to get in the habit of splitting each thing up, so when we get the function notation later, it makes more sense. Let me erase this so I can actually see this problem. Solve for x plus y divided by 3 equals 5. This is a similar question where these two terms, I'd like to isolate the term, I'd like to subtract y from both sides. The problem is these two terms can't be separated because they're glued on top of a wood plank. They're kind of glued together. So I'm going to undo this gluing, multiply by 3, multiply by 3. That will now release these terms and take them off the wood plank equals 15. Solve for x minus y, x equals negative y plus 15. Again, get in the habit of sending the constant to the end, the constant to the end. 15 minus y also would work. What you can't do is y minus 15. In this scenario, the 15 is negative. The 15 is supposed to be positive, so this one would be okay. If you did it this way, that would be okay. But again, we want to send the constant, the 15, to the end. So this one would be okay, this would be okay. This would not be considered okay. Number 5. Y equals mx plus b, solve for b. So this is the term. So I want to isolate the term that contains my variable. There's 1, 2, 3 term. Get this term by itself. Goodbye to the mx. Goodbye to the mx. I just have b equals y minus mx. That's all there is to do, because I've already solved for b. There's no more dividing I have to do. Number 6 is down here, solve for y. There are 3 terms, 1, 2, 3. This is the term that contains my variable, so I want to get rid of anything that does not contain my variable. by equals, I could do c minus ax, that's fine. Now I want to solve for y, so I'm going to divide this by b. I can certainly divide every term by b if you want to continue doing that. Y equals c over b minus ax over b. Every term gets divided by b. Or at this step, by equals c minus ax. We can divide by b and divide this whole side by b and have y equals c c minus ax all over b. These are really equivalent because it's just splitting up the b. It's like getting a common denominator. You could split it all up. Moving back up top to number 7, says solve for h. First thing you have to do is isolate the term that contains my variable. This is the whole term. So I don't have anything else to do. It is all held together. I'm done with step 1. Now this is technically all multiplication. So how do I undo multiplication? Just divide pi r squared. Divide this by pi r squared. Cancels, cancels. I have h equals volume divided by pi r squared. That's it. Don't move these things to the side, because if it's in the bottom, it has to stay in the bottom. If it's on the top, it can move to the side. Top can move to the side, bottom is locked in the bottom. Number 8 says to solve for y. Again, I'm very tempted to subtract x, but these are glued together on the wood plank, so I can't start undoing with subtraction. I haven't isolated the term. First thing I have to do is multiply by 2 and multiply by 2. That gets rid of it. Now I have 2a equals x plus y. And now these are separated. They're not held onto the wood plank anymore. They're not glued on. Solve for y minus x. Y equals 2a minus x. Number 9, while we're here, x equals yz over 6. Solve for z. Technically, this is one term because it's all held together by multiplication. But if I want to solve for z, I mean, there are other things you could do, but my suggestion to you is to get rid of this fraction by multiply by 6, multiply by 6. And I have 6x equals y times z. Continue solving for z, multiply by y, sorry, divide by y, and z equals 6x all over y. Z equals 6x all over y. You certainly could have, right from the start, x equals y, z all over 6. You could have multiplied by the reciprocal 6 over y times 6 over y. That y cancels that 6 cancels that, and I just have z equals 6x over y, which is the same thing. For number 10, a equals r over 2l, solve for l. Again, as with number 9, my suggestion is to get rid of the fraction part. It seems super confusing because l is in the denominator. Well, then let's just do this. Let's multiply by 2l, and get it out of the denominator. Now it's back to the numerator. 2la equals r. Now it's a lot easier to see. I've isolated the term that contains my l. Divide by 2, divide by a. Divide by 2, divide by a. L equals r over 2a. So the trick is, again, as soon as you can, get rid of the fraction. That's going to once again help us with number 11, which has a fraction, solving for b. You'd be very tempted to subtract a, subtract c, but again, they're not yet separated because they're all glued onto this wood plank. Multiply by 3, multiply by 3. I have 3a equals a plus b plus c. So solving for b, you subtract lowercase a, subtract lowercase c. So this side subtracts a and subtracts c. Actually, let's do it one at a time so you can sort of see it. I'll do a first, minus a. This is 3a minus a equals b plus c. Now I'll subtract this to c, subtract this to c. 3a minus c equals lowercase b. The last question, I'm going to erase this a little bit so I can see it. Looks like it's r minus c. P equals r minus c over n. Once again, you might be tempted to add c, but it's all glued onto this wood plank. Let's get rid of that wood plank, that fraction, multiply by n. Multiply by n. np equals r minus c. To solve for r, I add c and I add c. R equals np plus c.